Hi there. I'm Rob Miller from the Mozilla Cloud Services team, back in cleanup here, talking about a data processing tool we built called Heka. I'm not going to apologize up front for talking too fast because I have to. Heka is a data processing tool. We at Mozilla Services, we build services that live on the web, live in the cloud, and they run on servers. And one thing we've realized is when you run a lot of services on a lot of servers, you end up with a lot of data. A lot of different types of data, too. There is server-level, system-level operations data. There's process-level operations data. There's metrics. There's business data, log file output, error reports, tracebacks, you name it. The list goes on. Lots of different types of data. And we also discovered that in dealing with all of this data, there are lots of different types of tools. These tools all have very specific niches sometimes. They deal with collection, they might deal with stats data, graphing, etc., logging, log parsing, data processing, monitoring, notifications. We've seen a lot of them. And they all work in their own unique ways, but we realize they all follow one basic pattern. You acquire data from someplace, you transport that data, possibly transforming it along the way, and then output it to somewhere else. So we thought to ourselves, if this basic pattern is underlying so many different tools, what would it be like if we built a tool to handle this in the general case? We might end up with a little bit more homogeneity in the way that everything works. We might be able to share some of our work across multiple problem domains a little bit better. We might have less clients, less configuration. It would have to be lightweight. I'm looking at you, JVM. It would have to be flexible and configurable, easily extendable. And yeah, it would have to do the job pretty well. Now, we know there's lots of talk of replacing lots of different things with one single thing, and you end up just adding one more to the mix. We want to make our lives easier and not harder. But the good news is we don't actually have to replace everything. We don't have to boil the ocean here. All we have to do is replace maybe a couple of services on each box and do them as well or better than what was already there. We have an operational win out of that. And if we end up doing a really good job and replacing a lot of stuff and making our lives a lot better, then it was a successful experiment. So we're calling it science. And what we have come up with is a thing called Heka. Now, clearly, I'm not going to go through all of this in 15 seconds, but what we did is we broke down the process of pushing data through a pipeline into its core components and made each one of those a very pluggable and replaceable piece. So you have inputs that only deal with low-level transport. It doesn't deal with anything about what's coming in. It's just handling the I/O. You don't care if your protocol buffers came from the file system or from the network, whatever. That's all handled at the next layer where we split up the data and etc. Now, all of these plugin types, Heka itself is written in Go. It's a good, fast language, low-level, compiled, really lightweight runtime, and the concurrency primitives are well-suited to the type of work that we're doing here. But there are some downsides when you're building plugins in Go. Every time you add a plugin, a new decoder for extracting structured data from unstructured information, you have to recompile it into your system and redeploy it. And we know that there are lots of ad hoc monitoring and processing data or processing jobs that you don't want to have to do that for. So we also introduced the idea of sandboxed plugins, and we're kind of increasing where sandboxes can go. Right now for decoders, which extract structured data, and also for filters, which are where your actual crunching and processing happens. These can be sandboxable. There are Lua scripts right now where you can, I'll actually talk a lot more about sandboxes at the very end. So you can just know that you can inject these things, and then ultimately, of course, the data needs to be consumed somewhere. Maybe it goes to an external service, a data store, maybe to an upstream Heka that's running as an aggregator, maybe directly to some UI output. But we give you lots of plugins and some kind of hooks to do this. So back to sandboxes. The nice thing about the sandbox plugins is that you can directly, dynamically add them to a running Heka instance without any config changes, without having to restart the server at all. And the CPU cycles and the RAM usage of your sandbox plugins are going to be monitored. So this is really great. You can give your ops people the ability to write ad hoc scripts processing whatever data is flowing through the system, and you don't have to worry about them taking down production. If it misbehaves, it just gets shut off. We'll give you some parsing libraries. We'll give you circular buffer libraries specifically for dealing with time series data. And if you stuff your time series data into the circular buffer structures, then it'll automatically spit out these nice graphs for you on the Heka dashboard that we've installed for you. So the idea is to kind of give you like a D-trace for your data and give you the ability to push everything through one pipeline, do whatever you want with it, run it everywhere, have it be light and lean, and hope you try it out. Come talk to me.